And what that is that is a property, a characteristic of a substance that has to do with how it reacts with something else. Okay? So, does it have the ability to react with oxygen and form rust? Can you put a match with it and will it light on fire? Does it have the ability to react with a metal and form a hydroxide or a base? Those are the things that we're talking about when we're talking about chemical properties. Does it have the ability to react with something else? Like a banana. If you leave a banana out, does it have the ability to react with the air and turn brown? Next, you have physical properties. Physical properties or characteristics that are independent of anything else. So they're things like color. You can look at the color of something and it's not going to depend on whether or not it reacts with oxygen or whether there's nitrogen present or something along those lines. So it's something that is independent of anything else. It could be something like mass. It could be something like, is it brittle? Is it a lustrous metal? Is it shiny? There's all kinds of things that are physical properties, but it's something that you can measure independent of something else. A chemical change is one in which you are no longer the same substance. You are no longer the same substance. So, an example of that would be if you take water, you can split it into hydrogen gas and oxygen gas. And when you do that, you actually get two different substances. So you get oxygen and you get hydrogen, and you can actually use these things to make rocket fuel. This is an example of a chemical change because you've gone from water to something that is no longer water. A physical change is a change in the characteristics, but it is the same substance. An example of that would be if you take water that's solid, it's otherwise known as ice, and you heat it up, which is this little triangle symbol right there, you get H2O that's now liquid. But if you look, these things are identically the same. I didn't change the substance, I just changed what it looked like. I just changed the fact that it's a little cooler to the, or excuse me, it's a little warmer to the touch now because I added heat. It moves a little bit more freely, but it's still water. Intensive properties. Intensive properties are the ones that are do not depend on amount. So there could be one or two or a million or a billion, but the properties are the same. Things like color, things like density, things about whether or not they are conductors of electricity, those are all examples of intensive properties. Extensive properties depend on amount, and they're things like mass, volume, length, those sorts of things. Solid, liquid, and gas are the three primary phases of matter that we're going to talk about. And solids are, if you have a beaker, you have a solid material, it has a defined volume and a defined shape. These are F's. Defined volume and defined shape. A liquid has a defined volume but an undefined shape. A gas has undefined of either. A gas will fill up the volume of a container. It can be compressed, it can be squeezed together depending on the size of the container, and it will take the shape of the container as well. So it asks us to use these in a sentence now. So you should be able to come up with a sentence for intensive properties, something along the lines of density is an intensive property because the amount of material does not depend on whether something will float or not. Yes. Extensive properties, you can say things like mass is an example of an extensive property because the more of a substance there is, the more mass there is. Something along those lines. Okay, you should be able to identify the you should be able to identify the intensive properties that are here. You should know that density is an intensive property. Malleability is an intensive property. This is actually spelled wrong. Okay, and then conductivity is an intensive property, which means the other two are extensive properties. Okay, you should be able to identify the intensive and extensive properties that are here, but you should be able to say extensive, 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 intensive. So now it says to write the density equation. When we do that, the density equation is density equals mass over volume, and it says to solve for each variable. So when I do this, I can rearrange and I can solve for mass, and I can say mass equals. Now in order to get mass by itself, what I'm going to have to do is multiply this by volume, because mass divided by volume times volume, this will cancel out. But what I do to one side, I needed to do to the other, so I end up needing to put a volume over here as well. So mass is equal to density times volume. In addition to that, you could have volume is equal to density, volume is equal to mass divided by density. Okay, so now we have an example problem. And our example problem that we have here says that you have a 15 grams and 2.3 grams per mil, and we need to figure out what the volume of this particular object is. So when we do this, the first thing that we need to be able to do is we say, okay, my formula is density equals mass over volume. And when I do density equals mass over volume, I would say 2.3 equals 15 over V. Now, a lot of people will take this thing and do some strange things to this, like divide both sides by 15. If you did that, you would get 1 over V. Now, remember, 1 over the V is not the same thing as V. So, for example, let's say that you got 100 on your test. Okay? 100 over 1 would be a great grade, but if I gave you a 1 over 100, that'd be a really bad grade. So because of that, you really want to make sure that you're being real careful to solve for V, not 1 over V. And so when you do this, you actually have to multiply both sides by V, and you get 15 equals 2.3 V. Now you can divide both sides by 2.3, and when you do that, you end up getting 15 divided by 2.3 is 6.5 milliliters. Okay, the next one says an unknown gold-colored object has a mass of 5 grams and a volume of 3.68. Tell me if this is the unknown sample is gold or not. And the answer is, of course, it's not, because they don't have the same density. Remember, everything that is gold will have the same density. So because of that, you should know that the density of this thing is about 1.3. One matter that are covered in this class are solid, liquid, gas, which we covered in the vocabulary section, and also we may talk a little bit about plasma. Now, plasma is just a superheated gas that loses its electrons. So now it says which state of matter is not compressible and has an undefined shape. So when we say it's not compressible, that means if you take whatever it is and you squeeze it from all the sides, that it doesn't get any smaller in its volume. In other words, you can't push it and have it shrink. So we know that there are two things that are incompressible. We have solids and we have liquids. Those are the two incompressible states of matter. So you should be able to take those and say, okay, which one of these has a defined shape and which one has an undefined shape. Okay, and then finally you should know that it goes from gas to liquid to solid. Okay, it says draw a flow chart for all matter using the terms element, compounds, homogeneous, and heterogeneous mixtures. So this can be kind of confusing because the first thing you need to do is you need to start off with a question because you're going to have matter. Okay, and so what we need to do is we need to ask ourselves a question. The first question we're going to say is there more than one type of elements? Let's say atom. If yes, then it's an element. If no, you have a couple more questions you need to ask. If no, we need to ask another question. We say, okay, if there's more than one type of element, we say, are all elements bonded / connected? Okay, if the answer is yes, you have a compound. If the answer is no, you need to ask yourself another question. And you would say, okay, are all samples the same? If yes, it's homogeneous. If no, it's heterogeneous mixture. So that's just a way you can walk through it. So let's give you an example. So the first thing we have is salt, sodium chloride. We say, is there more than one type of element? Oh, I'm sorry, I got these mixed up. This should be no. If there's only one, it should be no, and if there's, this should be yes right here. Okay, so salt. Is there more than one type of element? No or yes. You would look at it and you say, yes, there's more than one type. So we go to the next question. Are all elements chemically combined or connected? So you would say, yes, they are. It's NaCl. So because of that, you would say this thing is a compound. Potassium is an element. Salt water is a mixture, and it is a homogeneous mixture. Okay, tap water is homogeneous mixture. Distilled water is a compound. Pond water is a heterogeneous mixture. Nitrogen dioxide is a compound, and oxygen's tough. It kind of depends on who you talk to, but it's generally considered to be a compound. So next, it says list three substances that are elements, compounds, homogeneous, and heterogeneous mixtures. That's up to you because there's almost an infinite number of those. So just make sure that they fit the definitions that we talked about. So now it says define the following terms. Physical property. We did this earlier. So a physical property is one that is independently measured. So in other words, it doesn't depend on the presence or absence of another substance. A physical change is a change in shape, but not substance. A chemical property is how does it react? So what does it do when it's mixed with something else? A chemical change is it changes into a new substance. So it says describe the following as either physical or chemical property or change. You should know that this is going to be chemical, this is going to be physical, 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 and this is going to be chemical. Okay, whenever you do this, the first thing that you should know is when you go through these, you should be able to look and say this is going to be physical, this is going to be physical, this is going to be, well, kind of both physical and chemical because you have a measurement and then you're mixing it with something. And then the fact that there are bubbles tells you it's chemical. And then record the volume is a physical. Okay, so that's the end of our Unit 2 remediation guided practice. If you still have any questions at this point, please make sure you talk to your teacher before moving on to the independent practice.